Okay, folks. So this is what I did with you today: observations and measurements. So the first part is it's quite simple to understand. So, like I told you in class, observation is when you make observations, right? In the world, we always make observations. We are always making observations about things around us. So it's very important. Okay. So science is all about observations. You observe something, and then you try to figure out why that something is happening. So here, talk about two things here, remember. One is called qualitative data, and the other one is called quantitative data. Okay, qualitative data and quantitative data. Now, when we talk about, excuse me, when we talk about quantitative data, right? Quantitative data, it comes from the word quantity. So any data which has number in it, let's say, like for example, 6.3 milligram, or let's say 0.2 degrees Celsius, or let's say 22.4 ml. All of this thing has numbers, right? So when they have numbers, they're called quantitative data. Meanwhile, qualitative data is data which has no number, and it's very subjective. Like for example, let's say like this color, the color that you're seeing now, is this green? Okay, is this green? Some might say it is apple green. Maybe some might say it is light green. Some might say it's pale green. So different people might look at the color slightly differently. So just like beauty, right? Beauty is also different. Some people might find somebody good looking. Another person might say that person is more good looking. So it's subjective. So that is qualitative data. Data which does not come with a number. It is not absolute. So scientific notations, we'll come back to this later. Now, there are 7 units, okay? Seven, you see this word here? You see this 7 system international or unit or SI units. Okay, SI stands for System International Units. This is a French system which was used, I think is used in majority of the countries in the world. So these are 7 base units. So they're called base units, all right? Base units. So everything else is derived from this. So mass is measured in kilograms, length is in meters, time in seconds, electric current in amperes, Kelvin, okay? Kelvin. So you say, hey, but you know what? Temperature we measure in degrees Celsius. I agree. But there is another unit which is called Kelvin. Kelvin is basically you take the temperature which is in degrees Celsius and then you add on with 273.15. Actually, that's called Kelvin. Amount of substance is mole. For chemistry students, this is very, very important. And luminosity of intensity is candela. This is, like I told you, we've never ever used this before. Okay, never used this before. Anyhow, these are called base units. Then from base units, okay, we can skip this. From base units, you come to something which is called derived units. Derived units are units which are derived from the base units, okay? So units that are a combination of base units are called derived units. Like for example, you see in volume, right? Volume is made up of height, which is meter, length, which is meter, and width, which is meter. So meter times meters times meter, you get meter cube, right? That would be volume. So same thing with density. Density is made up of mass and volume. And volume, I just said, is made up of a derived unit. So we take the base unit and we derive the volume. So density is also a derived unit. So these are other derived units. You do not need to memorize this, okay? You do not need to memorize this. But derived units are units which are made from other base units, like for example, velocity, acceleration, frequency, force, and energy. So these are the units you can see here. Meter per second squared, second, kilogram, meter, second, kilogram, meter. You don't need to memorize this, okay? There is no need for memorization. Accuracy and precision. If you look at this, right? If you look at this person here, this first shot, all of the shots are in one place, okay? In one place. So this is called precise. but it is not accurate. Accurate means it must hit the center, the bullseye here is accurate. You look at this person here, this person is precise because every time they shot the bullet, it hit right in the center, and they hit the center. That means they hit the bullseye, right? So they are precise and they are accurate. So this is the word, precise and accurate. So now you see, when you do these measurements, right, it is very important that the instrument that you are using must be very accurate. Okay, so look at this instrument here. You see, up to here it is 3.5. We are very sure, but here we are not sure, right? We are not sure. So some of us might say this is 3.6, some of us might say it is 3.7. So we are not too sure. But when we improve our instrument, you see this instrument is better. You look at this instrument here. Now we are very sure that this is 3.6. It's just that we are not sure what's the next number. So it could be, like, for example, it could be 3.62. Some of you might say it is 3.63 maybe. But you see the difference in the earlier example than this is, in the earlier example, we could only predict is 3.6 or 3.7. Now it is 3.62 or 3.63. So you see, now the accuracy has increased. In the initial example, we didn't know this number, right? Now is this number. So we are 100% sure that this number is correct. So our precision or accuracy has improved already. So earlier we only know one decimal place. Now we know two decimal places, all right? Okay, so then that brings us to significant numbers. Now when you look at significant numbers, right? You see, in these examples here, you can see that if there is a number and then another number, the zeros in between, all of them are significant. When we use the word significant, that significant basically means important. Okay, important. Important, that means they give meaning. Okay, give meaning to a measurement. They give meaning to a measurement. So that's why we call it significant. So you see, but look at this example, right? Any zero that comes before a number is insignificant, because you see this same thing, right? I can write it like this, 1.09 times 10 to the power of negative 2 kilograms. When I write it like this in the scientific notation, right, I go back to 1, 2. When I do this, I'm able to write it like this. So you see the zeros which were at the beginning, no need, we don't have to write them anymore. So they are insignificant, not important at all. Then if you have any zeros that follow a number, then especially in this case, there's a full stop here, right? So especially in this case, all of these zeros are significant. Okay, all of the zeros are significant. Now if you look at this example here, okay, please pay attention. In Muffy currently, what we do is we assume that this number is 1, 2, 3, 4, 5, 6, 7, 8, 9. We assume that this number is 9 significant figures. Okay, so we consider the zeros as significant as well. This is currently in Muffy. Only. Okay, the reality is we can write these numbers in many different ways. Just look at this, right? Look at this way. Okay, look at this. If you write it like this, it is 3 significant. But if you write it like this, it's 4 significant. So it all depends on how you want to write it. So the person who did the experiment is the person who will actually know how many numbers are significant based on the instrument that they were using, depending on how many numbers that the instrument gives. Okay, so rounding up, all right, rounding up numbers, I think you guys are familiar with this. Like for example, let's say 0.0265. Okay, so here currently this is 3 significant numbers, right? Let's say if I want to round it up to 2 significant numbers. So what do I do? 2 significant numbers will be up to here, isn't it? So this number here is 5. So what will happen is the new number will be 0.027. But let's say it was 0.0264, for example. So now I want to round it up to 2 significant numbers. So this number is less than 5. So it will be 0.026. It will stay as that, right? So if I want to round it up. So this is 3 significant. So it depends on what's the number just before you round it up. Okay? Like in both of these cases, if I want to round it up to, let's say, 1 significant number. So in both cases, it will be 0.03. This will also be 0.03, correct? Because this is 1 significant number. And the number next to it is 6. And the number next to it is 6. Okay. All right. So here comes the important part. Calculations. All right. Calculations. Now, when you do calculations, right, there you have two sets of types of calculations. One is addition and subtraction, and the other one is multiplication and division. Okay, let's do the easy one first. So let's say when we do multiplication and division, right, when we have something like this, what we do is we look at the final answer. Final answer must follow the least significant number used in calculation. Okay, least significant number used in calculation. So let's say, like, for example, right, I take 3.2 times 6.31 times 4.325 times 5.6676. Let's say I take these numbers, right? This is 2 significant. This is 3 significant. This is 4 significant. This is 5 significant. Okay. So when I do this multiplication, right? Okay, let me take my calculator. Let me just do this. Okay, so it's going to be 3.2 times 6.31 times 4.325 times 5.6676. Oh God. So the number I'm getting is 494,953,77504. I have a pretty good calculator. So this is the number that I'm getting. But unfortunately, I cannot leave my answer like this. I must write my answer with the least significant, which is this one. So my answer must only be 2 significant numbers. So it's going to be 1, 2. So it's going to be 4.9 times 10 to the power of 2. So this is where we do scientific notations, okay? So my final answer is through 2 significant numbers, right? My final answer is 2 significant numbers. And I have to write it in scientific notation. So scientific notation meaning it's like usually a number, okay? Let's say a number like 6, then point, then something else. Like it could be like 3, 4, and then times 10 to the power of 3. So this basically is 6340. That, okay? That's what scientific notation is. So the same thing happens with when we divide things. Let's say, for example, if we took let's say 5.6676 and we divided it with 6.31. Okay, let's say we do something like that. 5.6676 divided with 6.31. So my calculator says the answer is 0.89819333439. Wow. Okay, so if we look at this, this is 3 significant, this is 5 significant, 5. So the final answer must be 3 significant. So it's going to be 0.898 only. So it's 3 significant is only up to here. Okay, that is when we add and divide. We just follow the smallest significant. When we do plus and minus, okay, plus and minus, we follow decimal places. Okay, so least decimal. Okay, example. So what is decimal place? Like for example, right, like 6.325. This is how many decimal place? So decimal, this is a decimal, right? Decimal. And there are how many places after that? 1, 2, 3. So there are 3 decimal places. Okay, so let's say, like for example, we have like 10.34675. Let's say something like this, right? So after the decimal, this is the decimal. That's the decimal there. How many numbers do we have? We have 1, we have 2, we have 3, we have 4, we have 5. So this is 5 decimal places. So when we add numbers up, what we are going to do is we are going to follow decimal places. All right, let's look at this example given here. Okay, so look at this here. When we add all of these numbers, right, when we add all of these numbers, let me use my calculator and do this. 0.43 plus 1.492 plus 22.3. My calculator gives me the answer 24.2222. But here you see this is what? 1 decimal place. This is 3 decimal places. And this is 2 decimal places. So our answer is going to be, see, 1 decimal place. That's it. Okay, so it has to stop here, 1 decimal place. Same thing here. When we use your calculator, 44.9 minus this is 3 decimal places. This is 2 decimal places. So your final answer will be end up as 2 decimal places. So we round it up. So we bring 1 here and you get the answers 43.74. That's it. Okay, so that is how we do significant numbers calculation. Okay, so oops, sorry, I'll stop here and then we will continue with the other parts. So we're going to do the worksheet, right? The worksheet on significant numbers.